Bismillah ar-Rahman ar-Rahim. Today we will discuss applications of Bernoulli equations. There are so many applications of Bernoulli equations in which we will discuss only two. Number one, atomizer. Atomizer means paint spray machine, simple spray machine, spray machine, paint spray machine, or just spray bottle. It works on Bernoulli principle. Bernoulli principle is clear. When there is decrease in speed, there will be increase in pressure and vice versa. Similarly, when there is increase in speed, there will be decrease in cross-sectional area. There will be decrease in the area of the stream. In the present case, we have an atomizer spray machine. So this spray machine is of different types. In the present case, here we have fluid water. But sometimes this may be perfume, sometimes this may be paint. The basic principle for all these is same. How paint spray machine works. So look to the diagram we have sketched. Here is a tank which is called paint tank, in which the fluid is present. In the present case, it is a viscous paint having a horizontal tube and a vertical narrow tube. Here we have also an opening. Whenever air enters from the left, it will go in such a way that part of this air molecule will move in the horizontal tube, and part of this air, this is collective air which is coming out from the surrounding, from the outside of the tube. This is surrounding air. So when we punch the pedal of the machine, air will suck into the tube. Air will suck into the tube. Why air will suck into the tube? Because when we are pushing the pedal, this pedal, when we are pushing this pedal, what will happen? The pressure inside this tube will decrease. I am talking about atmospheric pressure. So by pushing the pedal, pressure inside the tube decreases. This pressure will decrease. Now Bernoulli say that when pressure is decreasing in that region, molecules of air will come to that region. So air from the surrounding will enter to the pipe. This horizontal tube, just you say it pipe. Now we have first outlet for these air molecule. Portion of these air molecule will enter through the paint tank, through this channel, and some will go ahead. Now what will happen here? When these air molecules enter to this portion, they will push down the paint. This is a viscous paint. So the air molecule will push the paint in the downward direction. You know that fluids are incompressible. It is liquid. It is paint. Paint is incompressible. We can't compress paint. But also we say that there is an external output force. Pressure will be taking place on this paint. The paint has just a single root with which it can go, and this is the root. So this paint molecule will move into this narrow tube. When these paint molecule come here, this air is mixed with this paint, and we get paint air mixture. Paint air mixture. Here we get what? We get paint air mixture. This is paint, and here air is mixed with this paint. And this is the nozzle through which the paint will come out. But now it is not just a paint. Now it is air paint mixture. Here we see molecules of air also. Air paint mixture. We accept that paint is a viscous, but here the tube is very narrow. So instead of just like water is flowing in a tube, in a canal, but when this water is coming out from our gas, from a narrow opening, it is converted into bubbles, spray. In the same way, here we get air paint mixture, but this paint is in the form of paint vapors. This paint is in the form of bubbles, small drops of paint, which is in the form of spray. The second thing which we have observed that whenever the paint is coming out of the nozzle, it is either already charged. We have charged it negatively. This paint is already having a negative charge. Or if it is not so, when the paint bubbles are coming out of the nozzle, they are rubbing with the nozzles and with each other. And you have studied in class 10 that whenever we rub a pen in our hair, it will attract pieces of paper. What does it mean? It means that by rubbing, bodies get charged. So when the paint is coming out, these paint molecules, these paint bubbles, they are just like charged bodies. And also you know that charge will enter to a portion, to a place which is at altitude. Just like in class 10 you have studied that thunderstorm will occur on the peak of a mountain, not on the trough, not in a deep place. Thunder will fall on a tree, not in the will. So in this way, we have placed here, let's suppose this is a table and we want to paint it. So these molecules, these paint drops will come and will fall on the table, not on the ground. And good carpenters, good painters, they know to make this furniture earth. So when these bubbles they strike the table, the electrons are shifted to the earth, and here inelastic collision take place. Inelastic collision take place in which it is impossible for the paint to be isolated from the table. Okay.